Hello, I'm Jasmine. I'm a course advisor in the Western Australia office. I just wanted to check if everyone can hear me. Wonderful. Thank you so much. Thank you so much, Maxwell. So we'll be proceeding to the notifications and sound section. Good morning to you too, Regis. So on the screen, we have some instructions just so then you can turn off your notifications and sound so then you can focus a little bit easier. I'll leave this on here for just a moment so then you can go through the motions. Fantastic. So today it will be the insights into EIT's remote and virtual labs, which is really exciting. This will be presented by Dr. Harisinh, Parmar, and then Dinesh and Austin. Thank you so much for joining us today. So just a few common questions in regards to the copy of slides and video recording. This will be emailed out in the next 2 business days, as well as the certificate of attendance that will be provided towards the end of the session. We will also have a prize that you can enter, and I'll provide further details regarding that at the end as well. Just a little bit about EIT. So EIT is a private institution that specializes in just engineering. So we do everything from professional certificates all the way up to a Doctor of Engineering, all very much industry specific and orientated. This is delivered by industry experts. All of our academics are all engineers themselves, which is really amazing. And we are accredited, so we're accredited through the Australian government and also internationally as well, which is fantastic. We really focus on specializing in just engineering. So we did a government survey, and as you can see here, we did come first place in a few different sections, which is really exciting. So this survey is conducted by the government through our students, and this is what they reported to be the case, which is amazing. And we really strive to provide the best quality education. You can see here that we won a few awards due to excellence in delivery, which is amazing. So both internationally and then the Western Australia Export Award as well, which is really exciting. Onto the agenda for today. So we've passed this section. I'll bring Harisinh onto the screen. Oh, I'm not too sure. Wonderful. Okay. I'll pop myself off of the screen and I'll hand over to you, Harisinh. Thank you so much.
Thank you, Jasmine, and hello, everyone. So let's start with the agenda, and you heard it right that we are talking more about our remote and virtual labs. So what's behind that remote and virtual labs at EIT? That's where we are starting our agenda with. So welcome and introduction has already been done by Jasmine. So and the about EIT as well. So I will start from agenda number 3, and then we'll talk about a bit more about different points on virtual remote labs. Okay, let's start that one. So more about me is that I'm a on-campus lecturer and laboratory coordinator at EIT, a Western Australia Perth campus. I'm a chemical engineer and worked with computational fluid dynamics at a lot. And in EIT, I am leading the hydrogen-related courses and also responsible for remote and virtual laboratories as well. So now the question would come to your mind that what is virtual and remote labs? Okay, so let me try to break down and try and explain that after this slide. So in this slide, you will see that when you do the engineering education at any institute, hands-on workshop or hands-on practical experience is the critical part of engineering education. Okay. Now at EIT, we have a unique model where we have online courses running as well as on-campus courses running. So we have adopted two different approaches to provide the same experience with remote and virtual laboratories. So you can use different simulation softwares to learn software tools, as well as we have remote labs where you can operate real equipment online in real time. Okay, so that's where that's remote and virtual laboratory comes into the picture. Now, how it works? So basically, we have, and you can see here that we have different campuses. We have campuses in Western Australia, South Africa, and United Kingdom, UK. And all those campuses and the remote lab servers, which is Electromeet servers, and local lab servers, which is connected to our equipment. So it's connected to the internet, and any of our students can log in at any time. 24/7 is available. So at any time, and can be able to do the practical. So what are the unique selling point of this? We have a traditional lab, but you can operate at any time in real time, accurate representation of current industry hands-on. So as I mentioned previously, that all these engineering courses are embedded with practical experience, practical exercise. Without practical exercise or experience, engineering courses are not fully completed. So accurate representation is given in terms of remote and virtual labs. We have somewhere around 25 to 30 or more than that remote labs available. So there is no issues of having the unavailability, right? And access is guaranteed. There is no geographical barrier. And in terms of speed, we have good bandwidth. So no issue about connecting to the remote lab as well. So now let me give you a bit insight into how you can connect to the remote lab, or how our students are connecting to the remote lab. So let's take an example of our current students. So we are using Moodle as our learning management system online. Through the Moodle, you can log into the Moodle via your student account. And once you log into the Moodle, you can go to the home page if you want to connect to the remote lab. So click on the home page, and that's where you can get the remote lab shortcut. Click on that remote lab shortcut. And now via the remote lab shortcut, you can have a access the lab button tab. And that's where you are connecting to our Electromeet server. You can see that the Electromeet server, you will see a different remote labs. Now, different remote labs are equipped with different softwares. And you can see that now, I think I'm checking that. Are you seeing the slides that I'm presenting, right? Because I can see one of the chat that they cannot see the slides. Is that the case, or can we see the slides that I'm presenting? Can you please confirm that before I move on? Yes, so I think you need to click with the sync with the slides. Yeah, okay. So oh, yeah. Going back to the presentation now. So now we are onto our Electromeet server, and that's where you can see a different remote labs. Now let's say you want to use one of the software that is in your practical assessment or out of curiosity, you want to learn new software tools. On the search box, you can search for a specific software such as MATLAB, AutoCAD, Autodesk Inventor, or PSCAD, or PSeam, any software that you like to use that one. And our Electromeet server will guide you through that which remote lab number will have those softwares available for you to use. Based on the information, you can click on those remote labs and book a time. So let me show you. So this is the calendar. It will open when you want to book a time. Sometimes the lab is not straight away available. As I mentioned that it's highly possible that it is available straight away, but if it's not available straight away, you can book the time. And when the time is come, you can see that green symbol comes to your calendar, and that's where there is a time for you to jump on the remote lab. And you will see the green bubble in the bottom of the remote lab. And at the time, you can jump on the remote lab and start working on the specific software you are trying to work on during your practical assessment, or whether if you want to learn that particular software. Okay, so that's where our remote labs, and we have a huge software availability in terms of all the electrical engineers, mechanical, civil engineers, and industrial automation. And you can use those software on our remote lab 24/7, and there is no limit on where you are located. Okay, so that's about our remote lab Electromeet platform. Now let me guide you through a different types of approach that we are trying to achieve this experience of remote and virtual labs. So now traditional versus learning experience. Now everybody is aware of our traditional learning experience, right? So let's say if we are doing engineering degree somewhere or even at EIT, you know that you are doing all the practical hands-on experience face to face. We have that available in terms of our workshop, BXX workshop, that I will cover that bit later on. More detail on the BXX and MXX workshops. But traditional experience is one way of learning the practical side of your concept that you are trying to learn through your engineering education, right? So this is the traditional experience. You can see in this photo that we have different, like students are learning concrete, fresh properties of concrete and serving activities through their practical hands-on experience. But at EIT, we are adopting different approach. And that's where these three ways where we are converting our traditional experience to interactive online mode. You can see now we have three different approach. One is the simple ones that you can record the video of traditional experience, which we are running in real time, and then convert into the interactive experiments. Now, this is not something, let me tell you that this is not something that you just record the video as a YouTube video and just look at the video. Okay? We are adopting the H5P tool to make it more and more interactive. Okay, so that's where I'll come to that point. The second is the simulated experience. So you can imagine that some of the experiment we have adopted the tools like Unity Pro, and Unity Pro will convert that particular experience in a simulated environment, and you are running that experience or experiment while you are in the simulation mode. So that is the second approach. And the third approach is a really good approach where you are operating the equipment in real time remotely. Okay. The experiment or the equipment is situated in Western Australian Perth campus or any other campus of EIT, but you can operate in real time. So let me get into the more detail of the first approach. That's where we record the video. We use our H5P interactive tool to convert that particular experiment into the interactive experiment, not the real-time video. Okay, so this is just an example of hydraulic circuit experiment. So we have recorded the video. Now we have edited that video in such a way now that we have broken down into multiple small videos that you can concentrate a bit more. At the end of the video, or even during the video, you can have a quiz, pop-up quiz, multiple choice quiz, drag and drop type of quiz. Those type of quiz are there during the video to make sure you understand the video and the content of the video, the concept behind the hydraulic circuit experiment, right? At the end of few video series, which is like, let's say we have broken down that video in 5 small videos. At the end of those 5 videos, you have an assignment from us to do the assignment in terms of, you can see here that assignment, you need to do the um, experiment, the simulation experiment on making the hydraulic circuit using that any simulation tool. Okay, so basically we are targeting and evaluating here with the simple video, making it interactive first. We are saying that whether you learn those skills that we are trying to show you or demonstrate you during the video within the quiz and the pop-up quiz, multiple choice quiz. At the end of the videos, we are trying to give you the assessment or the assignment related to the hydraulic circuit experiment. We are requesting you to draw that hydraulic circuit using a software tool, and you can submit that uh, assignment using, in this particular case, we are using Fuel Sim software to draw a circuit. So it's we are trying to achieve this hydraulic circuit experiment. Basically started with the simple video. We have created that in an interactive mode using H5P, and we have given you the quiz and assignment. And once you submit the assignment, we are closing the loop of this this experiment and the experience of learning interactive way of hydraulic circuit. Okay, so this is one way of converting a traditional experience into the interactive exercise. The second way, as I mentioned previously, the simulated experiment, and we are converting. This is a very good experiment and example that we are using at our EIT campus, and these electrical isolation procedures that we are using for our industry partners like Rolls-Royce and BP and Chevron. That's where we are giving them this short course of electrical isolation procedure. You can see that these procedures work in a simulated environment. So basically you are going yourself as a simulated environment, choosing 10 items for the electrical isolation work. You assume that you are opening the box with those equipment and start working on the isolation procedures step by step in a real simulated environment. So this is a second way of converting a experiment or the traditional experience into the simulated lab. Another example of remote and virtual lab is that we have a walkthrough system, and you can walk through the plant and check the distillation column, the storage tanks, and check those data that you can see on the slides, different types of data you can see. It's called virtual field operator, VFO. Okay, so VFO is the tool where you can log in with the given ID that we can provide the ID to our students. And you can see that you can walk through. You can imagine that you are walking in the plant, walking in the refinery, working in the plant where we are generating some chemicals or any other plants that you can think of, right? Oil refinery is a good example. So basically you are walking through the plant, you are near the pipelines or near the absorption column or distillation column. You click on the column and it will give you those data out of it that I have just presented those data before, and you can walk through those different equipments, pipelines, valves, and check the pressure, check the temperature. So basically you can imagine that you are on the plant, walk through the plant, and you are checking different equipment, checking the parameters in the equipment in real time. So this is a virtual field operator that we are trying to achieve through different learning experience. You can see that in this particular example, you are walk through the plant and ensuring that all the plants and equipment are operating efficiently and in a safe manner, right? So this is virtual field operator things that you can have a second way of converting the traditional experience into interactive online mode. The third way that is very, very interesting. The third way is where we have few really good example to cover here. And the one example is to convert the traditional experience into remotely operated experience or experiment. You can watch that particular equipment running in real time with the webcams, and you can press some buttons to switch on and off and running that particular experiment or the equipment. One very good example is the production line training system remote lab that we have at our Perth campus. You can operate that equipment in real time by connecting to a remote lab. So let's say the procedures I have mentioned previously to connect to the remote lab, and once you connect to the Electromeet server, you can find this particular production line running system remote lab. If it's available, you can straight away jump on that particular remote lab and start operating this equipment in real time. Let me show you that video let me show how I can share my screen and show you the video of our remote lab. I hope you can see my screen, right?
Unfortunately, we cannot.
Sorry, Jasmine, I think you mentioned something.
Oh, sorry, I couldn't before, but I can now, which is
Okay.
fantastic. Sorry.
And just one more thing, I just want to make sure whether you hear the audio from the video or not. So I'm just presenting for 2 seconds. Can you hear the audio or not?
Not yet, Harrison.
Sorry?
Not yet. We can't hear it yet.
You can't hear the audio?
No, I think you need to share with audio.
I'm sharing with the audio. I'm sharing with the audio, but how do I do it in this Teams environment?
Maybe
how do I
it is
share with the audio?
Maybe the audio is delayed. Give it some time, possibly more seconds.
Okay, let me see that cast to the device. I don't know, not that one, but let me just let me just start the video.
No.
Unfortunately, we still can't hear the audio.
Harrison, at the top of the screen on Teams where the share button is, the arrow, if you click on that, at the very, very top where it says share content, and next to that it says include sound. Can you toggle that to on?
Oh, yes, got it now. Thank you very much.
Amazing, thank you.
Thank you.
Let me go back to the starting now. I think hopefully now everyone should be able to listen to the audio as well. Okay.
Hello everyone, my name is Felix. Today I will be showing you a manufacturing process control lab developed for EIT as a remote lab project. The automation workbench depicts a typical industrial workflow process in any of the industries. It comprises of 8 stations, with each individual station having a Siemens PLC that is controlled by a ladder logic program using Siemens TIA Portal and the pneumatic system for the robotic parts and movements. The system is configured with a start button, with start, stop, reset, and emergency buttons. The main aim of this project is to ensure that the automation workbench can be accessed remotely by online students. Here is the first station. The first station is actually the turntable, which contains the load to be fed onto the machine. And we have the robotic arm on station 2, which actually picks the load from station 1 and transports it over to station 3, like we're already seeing currently. And in station 3, we have some engineering processes going on, as you can likely see, like the cooling operation. And we have robotic arm in the next station, station 4, which picks the already fine-tuned load and transport it down to station 5. But station 4 has the ability to detect a good quality product. It either rejects or sends further to station 5, which is being transported by the conveyor belts. And the robotic arm of station 7 picks the fine load, takes it over to station 6, where another little load is fitted into this, and it picks it up and finally transport it down to station 8, which is for storage. Right now, I'm going to show you how the interface of the TI portal looks like on the system. Like we could rightly see, from my left, we'll have different tabs, which contains the internal PLC ladder logic for the workbench, ranging from station 1 down to station 8. And to my right, we have the actual ladder logic, which I'm going to show you right now how to turn it on remotely, which is exactly what the students are going to do. I'm going to show you how the system can be turned on remotely from the TI portal interface, which is on the screen at the moment. Now right-click on the Start button from the ladder logic. Yep. Click on Modify and click on Modify to 1. Now the system is running. The robotic arm from station 2 picked up the load from station 1 and dropped at station 3, which we can rightly see. And drilling operation is going on in station 3, and the other robotic arm in station 4 picking up the load, the refined load, and transporting it down to the next station, station 5, which has the conveyor belt. And the robotic arm from station 7 picks it up, transports it down to station 6, where another little fine load is fitted into it, and the same robotic arm picks it up again and finally transports it down to the last station, station 8, where the storage is being done. There are a lot of benefits associated with this workbench and remote lab, of which they include PLC control and programming, sensor applications, and pneumatic applications, and how they are being very practicably applicable in the real world. Also, the students should be able to evaluate and select programmable controllers and associated hardware equipment for process control applications. Also, develop control programs for a process application and troubleshoots.
Let's go back to the presentation now.
You see the presentation?
Yes.
Fantastic.
Let me take control. Yep. So I think it's disappeared again.
That's so odd. I'm not too sure. I'll try and share it again. Just one moment, please. Thank you. Harisinh, on your left side of the screen with the presentation that's popped up there.
It is gone from this left side.
Okay. I'll try and share that again.
Yeah, so while Jasmine is bringing the presentation back, so you should have seen that in video that you can be able to operate that production line turning system, which is a replication of the automation in industry, right? And you have seen that production line turning system is a good example where you can see we use these similar type of systems connected to PLC and running on in any industries, any production packaging industries, right? So that's where this production line. Now you should have seen that the ladder logic during the video. Now what we have done it in the next slide. Thank you, Jasmine. Now I can take control. Yep. And in the next slide, you should have seen now that this particular ladder logic or the control we have converted into the graphical user interface. So you can select the number of loops that you want to run. You can select the different activities, like you want to put those black and white, white, black and black, this kind of activities. So different programming methods to run that production line training systems. And you can select and run those for you to learn different types of ladder logic. If you want to reject the any colors or any damaged packaging in a real life scenario, you can reject that with the sensor. So this type of different programming and ladder logic you can learn with this particular remote lab, which you can operate remotely from anywhere, right? So this is a good example of running. You can see that, yeah, I have started this particular video that you can see. I think again, yeah, that's presentation is disappeared. So basically the screen is that graphical user interface. That's where you can operate this production line training system remotely when you connect to the Electromed server. Okay, so this is the one that we use. So basically we have converted this particular, now you can see this one, yeah. So we have 8 different stations: loading, transfer, process, inspection process, air transport, and then install traffic. So different stations, that's where you can be able to.
Sorry to interrupt. Have you taken control of the slides?
No, I have taken it before, but last time when it's disappeared, now I have taken the control again.
Okay,
You want me to start to, yeah, you want me to go to the slide that, yeah, let me just go to the slide. Yeah, again, it's disappeared. Yeah, coming back, yeah.
Okay, just one moment.
You want me to take the control or just, yeah.
Did you take the control last time?
No, last time I took the control, but this time still not, I won't take the control.
Okay, please take the control and then see, because what might be happening is I might have flicked through and put it to the right section.
That's fine,
yeah. Thank you.
Okay, so yes, so I think that's where we were, right? Okay, so let me play the video again. I think we missed that video. I don't know it's going, but yeah, let me just explain that video in a brief manner. That this is just a graphical user interface, and you can use this interface to control the production line training system remotely and using different configuration or different ladder logic that you can learn. Okay, so that's where I have covered 3 different ways to adopt the traditional learning experience that you can learn in engineering in a different way at EIT, converting the remote lab, using the H5P, taking the video and converting into the interactive practical experience, converting to the simulated experience. And the last one is controlling the real experiment via remote lab, right? So these are the three different way we are doing the active collaboration and learning throughout the course. These are the 2 or 3 different examples of remote labs. We have the VFD and motor control via PLC. The same way you have seen the production line training system. This is the variable frequency drive and motor. You can control with the graphical user interface and a PLC via remote lab using the remote lab system. This is one more example of squirrel cage induction motor that you can control via remote lab. Now let's just move to the next topic of this presentation, which is called hands-on workshop and work integrated learning, WIL. Okay, I mentioned to you previously when I started the presentations that traditional experience, we are providing that experience throughout the workshop, BXX workshop and MXX workshop for masters. So that workshops we are running in an intensive mode, full-time Monday to Friday for 3 to 4 weeks. So the first weeks we are covering the measurement science, and it's common to all disciplines, civil and structural, electrical, industrial automation, and mechanical. The second week of the workshop, full-time workshop, we are breaking down into 2 different sessions. Mechanics and assembly workshop is for our civil and structural and mechanical engineering students, and power and control workshop for our electrical and industrial automation students. Week 3, that's where we are further breaking down that structure. The construction and surveying workshop is dedicated to our civil and structural student. Transmission and protection workshop for our electrical and IA students, and process plant workshop for our mechanical engineering students. Week number 4 is the workshop. That's where we use seminars and professional practice workshops. That's where you learn different soft skills and simulation tools to use it in the industry. So that's 4 weeks of workshop where we are providing the traditional real hands-on experience. You can see some of our students are working with different equipment, and the work integrated learning is the 240 hours of training that you need to go and do it in industries. So the placement, it's called placement, so known as internships, or you can go to the real industry, you do the project there, and that's where you can have that work integrated learning activities embedded in this umbrella. Now, why this industrial experience and workshop is really important, as we already covered and learned that before, that engineering education is incomplete without hands-on experience. So that's where we are covering BXX and MXX workshop and work integrated learning. You can have opportunity to try something new. You see that how people are working, engineers are working in real industrial life, real working experience. So you have exposure to the real working experience. You have opportunity to showcase your talent, your skills through the industry. And let me tell you that most of our students are going through work integrated learning, their first job with that particular industry as well. So if you have opportunity and you showcase your skill, they will absorb you as a intern or a graduate engineer, right? So that is where the industrial experience is very, very important. This particular internship and 0 credit unit, that is BXX workshops, 1, 2, 3, and 4 hands-on workshops. MXX is a professional practice hands-on workshop, and MXX 510, which is work integrated learning from a professional experience, 240 hours of engineering work experience. So that's where an industrial experience for a bachelor student is BSc 210. So these are the unit which is very critical and important units to learn about hands-on experience and work integrated learning. So now I'm giving back to the Jasmine, and probably then our students are share their experience with you guys. Thank you very much, Jasmine and students.
Hello, I suppose I will be taking next few slides. So at EIT, we deliver a number of different courses, as previously mentioned, one of them being professional certificates, diplomas, advanced diplomas, kind of goes on to Doctorate of Engineering. This is all very heavily focused on what the industry needs, which is amazing. Just that, and then we deliver online, and the methodology behind this is to provide and connect students as much as possible, which is ideal, and provide the most accessible education as well, which is really good for everyone involved, I would like to say, on campus. Dinesh, would you like to take this one? I'll just bring you on screen.
My name is Dinesh, and I've just completed my bachelor's from EIT last July, and here's how I would like to present myself with a quiet thought. I look back on my time at EIT, and this period wasn't just about learning facts. It was about truly taking in what I learned, changing me from someone who simply had knowledge to someone who was becoming more knowledgeable in my field and about myself. And how have EIT Remote Lab helped me to apply theory in practical way. The remote labs at EIT were key to my change. That how theory often felt like abstract idea. With EIT labs, it actually worked in real world. By watching materials and system behave, I moved from just having information to truly understanding it. And uh, yeah, can you share an example?
Sorry, Dinesh, have you taken control of the slides?
No, I have not.
It should just be at the lower left or upper part of your screen. There'll be an option in there. Can you see that option?
No, I think I cannot. The control.
Dinesh, do you have your bar at the top?
Yes, I think now I can. Yes.
Okay, perfect.
Well, thank you.
So just to confirm, can you see the transformation?
Yes.
Yeah. Okay. Thank you. Thank you. Yeah. Yes. Give me a second, please.
I will just share the presentation again. Just one moment.
Yes, please. That would be helpful, I believe.
Dinesh, if you look at the top of the screen, it'll say take control. Once the slide comes back up, top of the screen will say take control. You just click on that.
Wonderful. And I believe you can just scroll to where that slide was.
Sorry, I'm just scrolling through again. Okay.
No, that's okay.
The screen is too small for me. That's why I cannot read anything from the screen. And I'm trying to make it
Dinesh,
full.
there's three buttons there under more actions. You can just say hide presenter view, and then your screen will be big enough to read off of.
More actions. And then sorry, what was the options we are trying to?
Okay, more actions at the bottom. It says hide presenter view. It should be the first option off of there.
No, there's nothing such as that here.
At the bottom of the screen, right next to the number of slides that are there, there's three buttons on there.
Yes, there is, but and after that, I can see record and transcribe, video effects and settings, audio settings.
No, so I'm saying at the bottom of the screen where the number of slides are, not at the top of the screen. So next to 49 of 63 slides, there's three buttons down there, and then it's going to give you three options. Please click on hide presenter view so that you're able to get other slides. Is it good?
Right. Yes.
Okay, no problem. Thank you.
Yes. Yep. So one of the examples of project and experiment I did on remote labs is the elastic curve. When using remote labs, I could observe directly how the materials were reacting, not just theory, Sorry, I'm just going through a question there. Do you issue a document transcript or certificate after finishing a? I'm not too sure if I am.
Dinesh, I'll
Yes?
take care of that one. Don't worry.
Yep, all good. All good. Yes, thank you. And yes, I was just not learning from theory, but I could just see in real life how the materials were reacting, and they were behaving under different loads, and how they were reacting under real life. And I was also able to see the theoretical curve as well. This gave me not just a deeper appreciation about materials property, but also helped me in seeing how calculations were applied in real life. And the second question, what has been like to access engineering lab equipment from anywhere else in the world? Assessing the labs always have been it's always a very practical way to provide flexibility in our work and in our work with equipment without needing to be physically present, which also made learning more efficient, and it showed me how engineering tool can be used effectively across distance. Something that would feel relevant in today's industry, especially after the COVID era. It really made sense, and even after, not just about the academic, also about the practical, about saving resources and time. It really makes sense that if we are able to access engineering lab from anywhere in the world, it would be really handy to grow professionally and technically. And And what made you choose? What made me choose EIT over other institution? I chose EIT because it offered not only strong technical content but also personal support. By personal support, I meant the teachers were not just friendly but approachable and really attentive, which made my learning really fruitful. They were It made me engaging in what I was learning, and it was really and it was my experience my experience has been really positive, and I feel really grateful to have been a part full of such close and supportive environment. And what has been highlight of studying with EIT so far? With this one, I would say. This is my personal opinion rather than highlight of studying in EIT. For me, my biggest highlight is friendship I made here. Having friends, it was not just relying on my experience. They were not just motivating but encouraging, and they made me feel lighter when I was feeling a lot. And I'm not just talking about friends, the LSOs, the teachers. They were so supportive and they were so engaging that they wanted to know more without judging, with appropriate guidance and with proper knowledge. And with every boundary with every boundary touched and fulfilled, they gave a proper satisfaction of belonging. That's why I think the highlight of studying in the EIT so far, and that is still continuing. I'm continuing my masters in EIT. Is that the friends I made here, and the friends I will continue to make. Thank you so much, Jasmine. How is EIT preparing you for career in engineering and future opportunities? EIT has prepared me in many ways, not just first, yes, surely the technical training areas like design and project management, that has been valuable, but just as important has been emphasis on communication. Like I'm doing at this moment, I'm still preparing myself, I'm still learning, I'm still on the way, and EIT has given me this platform. Teamwork, of course, I'm here with such amazing teams, and so yes, of course, they are always helping me out and always giving me confidence, and they are my backbone and they are always my guidance. So of course, teamwork and problem solving. EIT has always been more than just a college. It has been my tutor. It has been my guidance as tutor in life as well. So no, problem solving not as just in papers in mathematical calculation, but how to become a good person, how to achieve better in life, how to come across small problems of life, which are more practical, not just in theories. And lab work, and of course lab also help you in academic practical theories as well. Yes, yes, and yes, I feel that EIT has shaped me into someone more ready to take responsibility for real projects, and the EIT also provide internship projects that is most of them, which is physical one, and I was one of the participants in internship. I did one online module, which was really useful, and which was really useful for me to learn practically as well. And the knowledge I got from LabWorks, online LabWorks, SolidWorks, and AutoCAD helped me in that internship. So yes, has prepared me, and it will still prepare me for a good career in engineering and for better future opportunities. Yes, and I would like to give the floor to my good friend Austin now. Hello, Austin.
Thank you, Dinesh. Yes, I'm currently third year right now. Let's see if I can take control. Okay.
Everything okay, Austin?
Yeah, sorry, I'm just trying to take control of the slides. Are you able to see the slides properly?
Yes. We are currently on
And they're
here.
moving. They're moving. Awesome. Yeah, so like I said, I'm third year now. It's my final semester. I most likely will be coming back for my master's, which is another 2 years on. There are a few reasons. Sorry, give me a sec. Okay. That's sorry, one sec. I'm just trying to change the view on my side. Okay, there we go. Yeah, so I've been there 3 years and studying. Lecturers are amazing, LSOs are amazing, and the people you meet, absolutely amazing. The remote labs and the easy access to them. Most unis, you'll actually have to go into the university to use the laboratories, being able to do it from the comfort of your home over the weekends when you get home from work. Any spare time you have, it helps you go over all your work, helps you go over everything again, look into it. I've submitted some examples. Being a mechanical student, I use the labs quite a bit. We use it for our hydraulic testing and everything because you will design units. And before you design the unit and submit it, you have to make sure it works. So there's software for that, which you're able to do once you get home. You're able to have access to it at all times. Yeah, like I said, you don't have to go into class for it. There are labs from all around the world, so there's always labs available for all your classes. Um, yeah, so you can see this right now is my capstone I'm busy doing, designing and making a centrifugal pump. It's all done on labs through our EIT. We will be running a bunch of simulations, testing, stress testing of material. All of that can be done on the labs. Design your part, put it in, and it will give you all the data of your stress, your strain, compression forces, all of that. So if you are working something out, you can get your answers and run them against the simulation and see where you've gone wrong. That does help you there also, because during the exams you won't have access to this, but understanding it and is there Joshi online lessons. Most of the software there is lessons as you need it. Your class teaches you the lessons and teaches you how to run the software. Also, you'll get a bunch of slides on the software as it comes up for testing and that if you need it. The university provides all of that, lessons, teaching. You're more than welcome to message your LSO or your lecturer. They always have time for you. And your lecturer will more than be happy enough to sit down with you, show you. And then once you get the basics, it's practice. It's up to you how good you want to get on the actual software. So you can see There's some of our designs, our stress testing, all that we do. Yeah, like I said, it's allowed me to take my hands-on experience, put it into actual tests, run the simulations, see that they'll work, and then write my papers on them. When it comes to your final year, you're going to need it. So it's not something I would ignore and only use once or twice. If you get a free chance, go onto the labs if there's a lab available, play around with the labs, learn the software. It'll always help you. The reason I chose EIT, one of the biggest reasons, it's a 3-year degree instead of a 4-year degree at most other universities. EIT is also way cheaper than most other universities. You get your course in 3 years, masters in 5 years, compared to a 4 or 6-year program. So you can get out there, you can get into work. Within 5 years, you'll have your master's degree, working, nice job. EIT with their work experience programs is something that also makes them stand out. There's non-stop emails coming through about work integration programs and everything. And yeah, you just take them up on that. They'll put you into a field of what you're studying and you get amazing work experience. Something EIT does, not many other universities do help you that much. And they will help you. And that goes on your CV. And if you do like the company they set you up with, you can always look at staying with them. Yeah, so like I said, I've gained practical industrial experience with the labs. You get to learn a bunch of, not with the labs, but your workshops. You get to do a bunch of experiments, bunch of hands-on stuff, which does correlate and it's stuff you can take back into the real world. Yeah, it teaches you all of that. Yeah, that would be all from me. I believe the rest is for you.
Wonderful. Thank you all for coming and joining us today. And thank you, Dinesh, Austin, and Dr. Harrison. I really appreciate it. I will provide a link to this draw at the end, but you can enter to win a prize of 2,000 USD with 10 runners up being, I think it's 100 USD each, which is pretty amazing. I'll provide that link for you now. Just one moment, sorry. Apologies for the delay. Please do let me know if there's any issues with any of those links. And then we have had a few questions throughout this session. I'll bring you back onto the screen, Dr. Harrison, just in case you would like to answer any of these. Don't believe we've had any through the Q&A section, but we have had some in regards to
Let me
attendance.
scroll through. What was the question? Let me check and then, yeah.
There was one in regards to certificate after finishing a professional certificate. That was by Sky, in which you would receive a certificate, though they are informal qualifications. And then I think one of the ones, is the time to attend online lectures fixed or is it flexible? I believe they're flexible.
Basically, for the online lectures, you can attend live And we do record those sessions, so sometimes if you cannot attend live, you can watch the recordings.
So just sticking with the online lectures, attendance-wise, I believe you have to be present for your lectures, but they do record them and they will be put onto your Moodle page. So if for some reason you miss a lecture or anything, everything's recorded on your page and you can go back and watch them. But for attendance, it's always best to just show up and you get marked attended.
Thank you, Austin. I really appreciate that. I think that's all of the questions we've had throughout the session. So we'll just go to the final section. I'm just taking you guys off screen. You can contact us throughout any of these methods. They're on the screen at the moment, which is pretty amazing. Thank you all for joining us today. I'll stop recording now. Wonderful. Thank you all. And should you have any